Good day, learners! Are you ready to have fun with math? How do you feel today? I hope you are all okay. I am your teacher Anne, and let's make learning more fun. Before we start, here are some reminders to keep in mind. Number 1. Stay alert and focus to the video lesson. Number 2. Prepare your pen and paper for your answer sheets. Number 3. Sit back and relax as you enjoy our learning for today.
Welcome back, all learners. Get ready to listen, try to focus, and be at your best. Before we begin, find a comfortable place, have your pen and paper with you, and make sure you have your module so that you can follow into our lesson on graphs of quadratic functions. Are you ready for our lesson? So let us start. The graph of a quadratic function f of x is equal to ax squared plus bx plus c, where a is not equal to 0, is called a parabola, which opens either upward or downward. It has important characteristics which are necessary to analyze, solve, and predict real-life situations. The important characteristics of a function are the following. We have the domain, which is the set of all possible values of x. The domain of all quadratic functions is all real numbers, meaning that is from negative infinity up to positive infinity. We have the range. It is the set of all possible values for y. If f of x is greater than or equal to k, then the range in interval notation is k up to positive infinity. And if f of x is less than or equal to k, then the interval notation of the range is from negative infinity up to k. We also have the x-intercept. It is a point on the parabola that crosses the x-axis where y is equal to 0. We have the y-intercept. It is a point on the parabola that crosses the y-axis where x is equal to 0. We also have the axis of symmetry. It is an imaginary line through the graph of a parabola that passes through line x is equal to h at the vertex and divides the graph into two congruent halves. Each side of the parabola is a reflection of the other side. The vertex h and k is the point whose coordinates are negative b over 2a and 4ac minus b squared over 4a on the parabola where the graph changes direction. When the parabola opens downward and a is less than 0, it attains its maximum value, while it attains a minimum value when a is greater than 0, and when the parabola opens upward. The direction of the opening of the parabola is determined by the vertex of the quadratic function h and k. When the range is y is greater than or equal to k, then the graph opens upward. And when the range is y is less than or equal to k, then the graph opens downward. As a summary, refer to the given figure at the right. The important characteristics of a function are domain, range, where in the given illustration, the range is f of x is greater than or equal to negative 4, or y such that y is greater than or equal to negative 4. The intercepts, wherein the x-intercepts are at negative 1, 0, and 3, 0, while y-intercept is at 0, negative 3. Axis of symmetry, wherein the equation of the axis of symmetry is x is equal to 1. Vertex, wherein the vertex of the graph in the figure is at 1, negative 4, and it has a minimum value since the parabola opens upward or a is greater than 0, and the direction of the opening of the parabola. Now, let's have illustrative example number 1. Are you ready to listen and learn? Then, let's have the given. The given is a function and not a graph. We're going to find the coordinates of the vertex, axis of symmetry, the point where it attains its minimum or maximum value of f of x is equal to x squared plus 4x plus 3, and change the function in the form f of x is equal to a multiplied by the quantity of x minus h squared plus k. To find the vertex, identify first the value of a, b, and c. The value of a is 1, b is 4, and c is 3. To find the vertex, use the formula for h and k. To find the value of h, we have negative b divided by 2a. And to find the value of k, we have 4ac minus b squared divided by 4a. It will be equal to negative 4 divided by 2 multiplied by 1 and 4 multiplied by 1 multiplied by 3 minus 4 squared divided by 4 multiplied by 1. Then, simplify. We will have negative 4 divided by 2 and 12 minus 16 divided by 4, or that is negative 2 and negative 1. The axis of symmetry is given by x is equal to h, or that is x is equal to negative 2, because h is equal to negative 2. The point negative 2 and negative 1 attains its minimum value, which is the vertex, and it satisfies a is greater than 0. Rewriting the function in the vertex form, f of x is equal to a multiplied by the quantity of x minus h squared plus k, we have the function 1 multiplied by the quantity of x minus negative 2 squared plus negative 1, or that is f of x is equal to the quantity of x plus 2 squared minus 1. I hope you can follow in the discussion. Let us have another example. Determine the important characteristics of the graph of the given quadratic function. With the given graph of a function, let us identify the domain of the function. The domain of the function is the set of all real numbers, or that is from negative infinity up to positive infinity. That means all the possible values of x are all the real numbers. Then, the range of the function, or the values of y, or the possible values of y is greater than or equal to negative 1. The x-intercepts are at negative 3 and 0, and negative 1 and 0. The y-intercept is at 0, 3. The vertex of the function is at negative 2, negative 1. The axis of symmetry is the imaginary line, which is given by the equation x is equal to h, where h is equal to negative 2. The equation of the axis of symmetry is x is equal to negative 2. The direction of the opening of the parabola is upward, since y is greater than or equal to k. The parabola has a minimum point. Now, let's have example number 3. For illustrative example number 3, we're going to determine the vertex, axis of symmetry, x-intercepts, y-intercepts, domain, and range of the given graph on the right. The domain of the function are the set of all real numbers from negative infinity up to positive infinity. How about the range of the function? Can you now answer this one? Very good. The range of the function is y is greater than or equal to 1. There is no x-intercept because the graph does not pass through the x-axis. The y-intercept is at 0, 7. The vertex of the function is at 3, 1. How about the equation of the axis of symmetry? Correct. The equation of the axis of symmetry is x is equal to 3, since the imaginary line passes through the 3 on the x-axis. I hope you were able to understand our lesson for today. Good job, grade 9 learners! Let us recall the important parts of our lesson for today on the graphs of quadratic functions. Let us have the summary of our lesson. We discussed about the characteristics of the graph of a quadratic function. We have the domain, which is the set of all possible values of x, the range, which is the set of all possible values for y, the x-intercept, which is a point on the parabola that crosses the x-axis where y is equal to 0, the y-intercept, which is a point on the parabola that crosses the y-axis where x is equal to 0, the axis of symmetry, which is an imaginary line through the graph of a parabola that passes through line x is equal to h at the vertex and divides the graph into two congruent halves. The vertex h and k is the point whose coordinates are negative b divided by 2a and 4ac minus b squared over 4a on the parabola where the graph changes direction, and the direction of the opening of the parabola, which determined by the vertex of the quadratic function h and k. When the range is y is greater than or equal to k, then the graph opens upward, and when the range is y is less than or equal to k, then the graph opens downward. That's all for today. Congratulations, dear learners! You did a good job. I hope you learned something worth giving and remembering in today's lesson. Till next time!